Hello students, good morning. So today this is our first lecture, online lecture for 11th standard. If you remember, in last period already we have finished the chapter scalars and vectors. The remaining part of the chapter, that is nothing but a mathematical calculus, that was skipped this year. So that we are not going into look into that particular topic. So today we are going to start a new chapter whose name is what? Mechanical property of solids. So let's start with this. Mechanical properties of solid. So solids are the materials which have some properties, and that properties are very essential to learn for us. For different applications, it is very essential to learn these properties, and that properties comes under this, that is said to be mechanical properties. Now why the mechanical properties are studied in this chapter? Because this is a chapter in which we are interested to learn mechanical property for certain use. For example, when we are going to build up a building or construction site, we have to use some iron rods in that. Iron rod, that is said to be steel. So that steel has different dimensions. For smaller building, the dimension will be less. For bigger building, the dimension of steel or amount of steel used in that must be the heavy steel we have to use. So that decide the strength of that particular building we have created and how much load it has. That is nothing but what? That strength was decided in terms of mechanical properties. That's why very essential to learn the mechanical properties here. And in this chapter, we are going to learn some of the mechanical properties of the solids. So before going into detail, there is one basic definition is that is said to be deforming force. What exactly deforming force? Before going to the deforming force, let's see what is meant by deformation. So here, this deformation means what? Deformation is nothing but one of the method or one of the process. If any material shape or size or both get changed due to application of any external force, if there is change in shape and size or both of the object or the body, then we can say that body get deformed. What exactly deformation? Due to application of some force on a body, if shape or size or both of the body get changed, then that applied force is said to be deformation. And that applied force is said to be deforming force, and we can say body is in the deformation. One of the best example for this, suppose this is nothing but a sponge. Might be all of you have known about sponge that we'll use in sofas and sometimes beds, sometimes cushions. They will made up of this type of sponge. Suppose we have a sponge and this is the width of the sponge, this much is the width, this much is the length of the sponge. Now when we apply some force on this, suppose some force F is applied on the surface of the sponge, it is seen that the dimension of sponge get decreased like this. Initially it is this much, now this much is a reduction in the dimension of that sponge due to application of this force. So what does it mean? When we apply the force, original shape, size of the sponge get decreased. Then we can say this body is under deformation. This body is under deformation due to application of applied force, and that's why this force is said to be the deforming force. So the applied force due to which there is change in dimension or shape, size or both of the body, then that applied force is said to be deforming force, and body is said to be in deforming condition. Apart from this point to be remember, now if you remove this applied force, now if you remove the force, I will draw it here. If you remove the force and body comes to its original shape like this, after removing this deforming force, if body comes to its original shape like this, then the body is said to be elastic body. Then the body is said to be elastic. Elastic means what? After removal of external applied force called the deforming force, if body regain its original shape and size again, then the body is said to be elastic. If it doesn't regain its original shape and size, then the body is said to be plastic body. So the phenomenon of regaining original shape and size of the body after removal of deforming force is said to be elasticity of the body. This property is said to be elasticity of the body. Okay, elasticity of the body, and bodies are said to be elastic bodies. If after removal of this force, if body never regains its original shape and size 100%, then that body is said to be plastic body, and the phenomenon is said to be plasticity. One of the best example for this we are going to learn here. So might be all of you are well known about these things that we have learned. That is nothing but what we have seen: the elasticity, elastic bodies, plasticity and plastic bodies. So let's start with one of the best example for this. Suppose we have the rubber cord or rubber band we have. Might be all of you are well known about rubber band. Sometimes we are using rubber. So suppose that rubber band we have taken, so such type of circular rubber band we have cut it here and make it straight. So we have made it straight. We have taken a rubber band, we have cut at this place and we have made it straight. Now this is the length of a rubber band. Suppose it is A, at this point it is A, at this point it is B. Okay, we have the rubber band. Now suppose I have applied some force from this side. I have picked this end, I have applied force from this side and elongate it further. If I elongate it further to the new point, here it is suppose B dash. What we have done? We have applied the force on end B so that we have elongated B to B dash. Okay, then this is said to be deformation of the body. Deformation of the body, and this applied force is said to be deforming force, and body is said to be in deformed condition. I hope you got this. What we have done? We have taken a rubber band, we have cut it here, make it straight AB. Then I have applied the force on the end B so that it get elongated to the new point B dash by the application of force F. Then this state of the body AB dash is said to be deformation of the rubber band, and this AB is said to be original shape of the rubber. Applied force is said to be deforming force. So this much we know, that's already we have seen. Just we are going to explain same thing by using the example. So this is for rubber states. Okay, now when you remove this force, F or deforming force on this body, what will occur? It is rubber. So this again, when after removal of this, the body regain, it come again to the original shape. Instead of B dash, it come to the B. Then we get rubber as the original shape, it is AB. Again it come to the original shape AB. That means what? We can say 100% body come to its original shape after removal of this force. And this property is a property of elastic materials or said to be elastic bodies. So rubber is said to be elastic one, is it? And that property is said to be elasticity. After removing the external applied force or deforming force on a body regains its original shape and size 100%. Then that property is said to be elasticity, and this is said to be elastic bodies. Apart from this, if you see second example for this, might be all of you are playing in your childhood with clays, duff, and sometimes of different things. Just like clay is well known to everyone. Suppose this is a clay, we have this bar of the clay. So this is the clay bar we have taken. Now clay, if we have taken, we can make any toys from this. Okay, we can make a toys from this clay. Now what we have done, we have applied some force from the top part. So when we apply some force from this top part, the shape of the clay get decrease. If we uniformly if we apply the force, uniformly I am saying. So I have made one plate here like this, and this plate I have applied here the force on the plate. So it get just we have kept it on this clay. Then what will occur? Initially clay is here somewhere. Now this much is what? Decreasing its height, we can say. So shape of the clay get changed after application of this force. So this is a deforming force, and this state is said to be deforming state of the clay. Now if you remove this force, when you remove this force, then it is seen in case of rubber, it will regain its original shape and size just like a sponge. But in case of the clay, when you remove the force, it never come to its original position. It remains as it is, deformed state. And this property is said to be plasticity. And the materials are said to be plastic materials or plastic bodies. I hope that all of you are well known about this. What we have learned up till now, we have seen what is meant by deformation. We have seen what is meant by deforming forces. We have seen what is meant by elasticity. We have seen what is meant by elastic material. Just like a rubber we have taken, we can take any elastic also. Just we have seen what is my plasticity. We have seen the plastic bodies just like clay. We have seen clay. So see, in your book they have given the deforming force definition on page number 100. If you see left hand side, they have given the definition. I will read it according to book. The change in shape or size or both of the body due to external force is called as a deformation, and applied external force is said to be deforming force. The second, they have just given 6.2 elastic behavior of solid. They have given definition as if body regain its original shape and size after removal of deforming force, then that is called as a elastic body, and the property is said to be elasticity. That already I have told you here. Apart from this, the same thing, the second paragraph of the first paragraph of this topic, elastic behavior. First paragraph, if body regain its original shape and size completely and instantaneously upon removing deforming force, then it is said to be perfectly elastic. See, perfectly elastic means what? Quickly. When you remove the forces, body regains original shape quickly. 100% original shape it came, and is said to be perfectly elastic body. Okay, and if it never come to its original shape and size, that body is said to be plastic body, and the phenomenon is said to be plasticity. So see, in your book they have given some examples. So examples of the elastic body they have given as a elastic materials, like a metals up to certain strength. Metals are elastic. Rubber, cords, these are the elastic materials. And what are the plastic materials? The putty, the clay, putty, plasticine, thick mud. Mud is also that we can make some type of things can be made from the toys, can be made from the mud. We can make oxes, and we can make animals, or anything we can make. We can make god statues also. So that mud is also nothing but what? They are said to be the plastic bodies. So here, this is in short, we have learned what is meant by elastic and plastic. So point to be remember, elastic materials are materials which can regain their original shape and size after removal of applied forces or deforming forces. The plastic bodies are the bodies or materials which never regain its original shape and size, just like a clay, after removal of deforming forces. That are said to be what? That are said to be plastic materials, and the property is said to be plasticity. So these things we have learned. Now apart from this, every material has some properties. The two properties that every material has, that comes in mechanical property, that we have to learn today. So what are that two properties that we have to see? So let's start with the first one. The first property is said to be stress. Might be all of you hear this word stress. Lot of stress human being have. Maybe might be you have the stress due to studies and something else. So this is stress. This is one of the property, that is nothing but a stress. So what exactly stress means? Stress means what? It is a property of the material. It can be explained as stress is how much force is applied on the object and divided by area of the object, that is said to be stress. Force applied per unit area. In another way, it can be said as force applied per unit area. It is called as a stress. How much force is applied per unit area, on unit area, how much force is applied. Their ratio is always constant, that is said to be stress. Force applied per unit area. In your book they have used the word restoring force per unit area. In your book they have mentioned this F as a restoring force per unit area. Now what is meant by restoring force? So here they have mentioned restoring force. Might be if you are, I hope all of you are well known about how to use a computer. In computer there is one app, or we can say there is one logo, that is said to be dustbin or recycle bin. Dustbin or recycle, special recycle bin. So recycle bin, such type of bin type of structure it would have like this. Such type of symbol is on computer. Suppose some file get deleted by us, by mistake we have deleted that file, we want to restore it, then what should we do? We have to go to recycle bin, click on that file, right click by the mouse, and just click on the restore. Once you do, the file automatically goes to the place from where we have deleted that. Do you got it? In computer, suppose by mistake I have deleted one file, I want that file again because that is useful file for us. Then in that case, to recover that file, we have to go to dustbin or recycle bin of computer. There is one logo in a computer, recycle bin. Right click on that file and just click on a restore option. Once we click on restore, the file automatically go to the place from where it was deleted. So that is nothing but a restoring of this any application or any file in computers. Similarly, here in case of this material, there is restoring force means what? Let's again go to the example of sponge. So suppose this is the original dimension of sponge. It is sponge, suppose we can say elastic material sponge. Okay. Now here, this is the dimension of the same sponge after application of some force that is said to be deforming force FD. We have applied some force from the top, so the shape or dimension of this get reduced. It goes like this. We have applied the force, it get reduced like this. Okay, that is we can say deformation. Okay, deformation of sponge. Now here, as a sponge is an elastic material, what will occur in case of sponge? Automatically some same amount of this applied force FD is said to be deforming force, or sometimes it is said to be applied force FA. When you apply some force on the elastic material, just like a sponge, any type of elastic material, we have taken a sponge or rubber we can take. So when we apply this force, applied force or deforming force on it, its shape get changed, shape and size get changed, or dimension and shape get changed. It gets smaller one. Now when we apply this force, what will occur internally? Automatically internally same amount of forces are produced in the material. Internally same amount of applied deforming forces are produced internally in the material, but their direction is exactly opposite. Just see, applied forces up to down, deforming forces are down to up. They are exactly same. These are FAFD, then these are also FA, or they are FD, deforming force or applied force. And this only difference is what? This forces has opposite direction. These forces are created inside the material. Point to be remember. Applied force we are applying externally. The inside flow forces are created inside the material internally. And when you remove the applied force, due to this internal forces, body come to its original shape if the body is elastic one. So these internal forces are said to be restoring forces. So these are said to be restoring forces. Restoring forces are the forces created internally in only elastic material. So when you remove this applied external deforming force, due to these forces, body come to its original shape and size again. Now the body come to its shape and size again, then we can say body behave as an elastic material. So that are said to be restoring forces. Internal forces created in the object, they try to restore the object. Restore means what? Try to move it to its original shape and size. That forces are said to be restoring forces, and they are internally produced in the material. So it's quite difficult to measure the internal forces. It's quite difficult. We can't go inside the material, we can't measure them. Then how can we measure? So here the best method to measure them is what? Whatever with the applied force we have applied, whatever with the applied force we have applied on the sponge, applied force, or it is said to be deforming force applied on the sponge, exactly same but opposite direction forces are created. So how can you measure the internal forces? Just you know how much force we are going to apply on the object. We know the FA, how much force we are going to apply. Same amount of forces in opposite direction will be created. That's why just by measuring the applied force, what we are measuring? We are measuring the internal restoring forces. We are measuring internal restoring forces, and that are equal to this applied forces. Directions are opposite. That's why they have mentioned here definition of stress. Force, restoring force per unit area. Restoring force per unit area. But we know that restoring force is internal forces that are exactly equal to applied forces. So this restoring force per unit area is nothing but what? We can write here applied forces per unit area. Applied force per unit area. that is nothing but a restoring forces. So in this fashion you can measure these values, or we can measure the property, that is just measure the applied force divided by area, how much area we are going to apply the force. By measuring this you get the one of the property of the material, that is said to be, the property is said to be stress. Mechanical force or internal restoring forces per unit area, or we can say applied forces per unit area, it is said to be stress. Let's go to next one. Second property we have to see, that is nothing but what? Strain. What this strain means? This strain in general means what? Change in dimension. CID is not criminal investigation department. A point to remember. It is CID means what? Change in dimension divided by OD, original dimension. How? Dimension may be length, it may be volume, it may be area, it may be shape, something else, it may be anything. So change in dimension divided by original dimension of the body is said to be strain. So point to remember, restoring force per unit area or applied force per unit area is stress. On any object we are applying force divided by area of that object is said to be stress. And due to that applied force there is change in the dimension of the object. So change in dimension divided by original dimension of the same body is said to be strain. In this fashion we have learned these two forces, or the two properties we can say, not the forces, stress and strain. Now let's see here. Stress is what? Force divided by area. What is the unit of force? Force is measured in Newton. SI unit we can say it is Newton. Area is in meter square. So Newton per meter square is a unit for a stress. Stress is always measured in Newton per meter square, or it can measure in CGS system as dyne per centimeter square. So this is nothing but a CGS unit. This is nothing but what? SI or MKS system. That already we have seen in 4th chapter. Okay, so Newton per meter square, SI system, dyne per centimeter square, CGS system. So that is the unit of stress. What about this strain? Do you know? Do you have any idea about this? What should be the unit of strain? Remember, it is change in dimension divided by original dimension. It is a ratio of two same quantities. If it is ratio of two same quantities, it is dimensionless and unitless. How it is? Suppose we are measuring the length. Change in length is whatever it may be, whatever be the number, but its unit would be meter. Suppose I have measured x meter would be the length. X meter would be the length. X meter, and suppose y meter is the original length. This change in dimension, what we are going to measure? Change in length divided by original length. Change in length is x, original length is y. X divided by y, both are measured in meter. So what will occur? This meter get cancelled out. So here there is no unit for this. So it is unitless quantity, or we can say dimensionless quantity. I hope all of you get about this. What is meant by the elastic material, elasticity, plastic material, plasticity, deforming forces, restoring forces. Then what we have seen, the examples of elastic materials, example of plastic materials. Then the two property we have explained, stress and the strain on the basis of this. Apart from this, we have to go further, type of stresses and type of strains. So how many type of stress and how many type of strains are there? It was decided by the dimensions. What type of dimensions are changing? So basically there are three variations. Change in there are three changes basically in the material. Change in, first, either length of the material get change, or its volume get change, volume of material get change, or third one is nothing but a shape of the material get change. Shape of the material get change. Length may get change, or volume may get change, or shape may get change. So there are three type of changes in a solids or materials, we can say. Change in length, change in volume, change in shape. And accordingly there are three type of stress, three type of strains. So see, whenever there is change in length, I will like this is change in length, I will write here stress, type of stress. I will write here strain, type of strain. Whenever there is a change in the length, the stress is said to be tensile stress or longitudinal stress. So this is said to be tensile, or longitudinal, stress. Tensile stress, or it is said to be longitudinal stress. Tensile stress, or it is said to be longitudinal stress whenever there is what? Change in the length. The stress is said to be tensile or longitudinal stress. What about strain? So strain is said to be same, tensile or longitudinal strain. Tensile or longitudinal strain. So same. So it is tensile stress, longitudinal stress. Here tensile strain or longitudinal strain. Apart from this, whenever the change in volume, it is said to be volume stress. In this case, it is said to be volume stress. Or in your book, they have mentioned it as a hydraulic stress. It is said to be hydraulic stress. Stress in case of stress. In case of strain, it is said to be simply the volume strain. It is said to be volume strain. Is it? And apart from this, if there is change in shape, if there is a change in the shape of the body, then in that case again there are stress and strain. That is said to be shearing stress and shearing strain. If the shape of the body is changing, then it is stress is said to be shearing, shearing stress if the shape of the body gets changed, and strain is said to be shearing strain. So these are nothing but what? These are the type of stresses according to these three shapes. These are type of strains according to these three shapes. If there is change in length, stress is said to be tensile or longitudinal stress. Change in volume, volume stress or hydraulic stress. Change in shape, it is said to be shearing stress. What about strain? Change in length, tensile or longitudinal strain. Change in volume, volume strain. Change in shape, shearing strain. I hope all of you got the three type of the stresses and three type of the strains. If we see here, these three type of stress and strains are given according to these three changes, and that's why there are these three type of stresses and these three type of strains. Now here just we have learned the type of stress and strain. Apart from this, we have to see how do you find the values. How do you find the values of stress and the strain? So let's start with the next one. I will write it here at the bottom just for tensile stress. The first stress, that is said to be tensile stress, or it is said to be longitudinal stress. In shortcut, I have mentioned it like this. This part we have taken. Tensile stress or longitudinal stress. What is the formula for stress? Just we have seen internal restoring forces divided by area per unit area, or applied forces per unit area. So this is what restoring forces or applied forces per unit area. That is said to be tensile stress, or we can say longitudinal stress. Is it? In this situation, how can you see this? Suppose I have this rigid support. I have applied this rigid support to one wire. I have attached one wire to this rigid support. Its original length is suppose capital L. Then at this bottom I have applied some force. I have applied at this thing up to this, the length is L. I have applied the force in downward direction, so length get increased to this part due to the applied force in downward direction. That is said to be load applied at the bottom. So this much is what the increase in the length, and that was represented by small l. So here how much force we have applied? F. Area of the wire you can find it out. So what we can put? Force applied is what? I will write here. Force applied is mg. Area of the wire. What is the formula for area of the wire? It is pi r square. So this is said to be longitudinal stress or tensile stress was given by force divided by area, mg divided by pi r square. Definitely it is related to length, so this is, I have drawn the diagram for a length. Once you got this, let's go to next one. I will just erase it. We'll go to the second type of stress. Or first we will see all stress, then we go to strains. Okay. So let's go to second type of stress. So what is that? Volume stress. Volume stress, or sometimes it is said to be hydraulic stress. Volume stress, sometimes it is said to be hydraulic stress. Now as we know, again it is what? Equal to force, restoring force applied per unit area. Restoring force applied per unit area. Now here restoring force applied per unit area is nothing but what? F divided by A, that is said to be volume stress. Force applied divided by area of the object on which the force is applied to change the volume. For example, might be all of you are well known about the balloon. We have blow the balloon like this. Okay, I have blow the balloon. I have tied the knot at the end. It look like this. Suppose we have tried to blow the balloon. It's exactly circular like this. This is a balloon we have blow. Quite difficult, I know. I have just blow the balloon. It is circular like this. Or I will draw it here. It is circular like this. Such a balloon I have blown. So such type of shape of balloon is there. Then what we have done? Suppose we have applied the forces from all six sided. How the six side balloon has? The four side from this right side, left side, up, bottom. Okay, apart from top and the back. So six sides balloon has. We have applied so constant force from all these six sides. We have applied constant force F from all six sides. What will occur? Initial balloon is big. When you apply the forces, its dimension get decrease. If the uniform force is applied, its dimension get decrease. What get changed? Volume get changed. Initially it is big, means volume is more. After applying these forces, the dimension get changed, volume get decreased. So there is change in volume, and that stress is said to be volume stress. The force applied from all six sides divided by area on which the force is applied, it will change the, it will change what? It will change the volume of the object, and that is said to be volume stress. Is it? So this is the volume stress. We have seen the volume stress, change in volume divided by original volume. In case of length, if you remember, we have just seen the increase in length. Okay. Similarly, length can be decreased also in metal also. Length can increase or decrease also. So if you have the book, then in your book there is a figure 6.1a, that is the tensile stress by increasing length. 6.1b, the compressive stress, that is nothing but a compressive, means we are decreasing length, compressing the length, that is said to be compressing strength. So that is 6.1 and 6.1 A and B diagram that they have given in your book. Now let's go further. Volume stress or hydraulic stress we have seen. Now the third and last one we have to see, that is nothing but what? Shearing stress. This one we have to see. So let's start with this third, shearing stress. So this shearing stress, again, force applied divided by area, but these force applied are said to be tangential forces applied per unit area. Tangential forces applied per unit area, because it is related to change in shape. So how can you change the shape? Suppose we have taken such type of one diagram we'll plot here. If we draw such type of one box we have taken, suppose such type of one cubical shape we have taken, and we have fixed this cube on the table. This is a table. On this table we have applied the Fevicol or some glue is attached at the bottom, and it was attached to this table and it was fixed here. This is a table. On that this box is fixed. Now when you apply some forces from this at the top of this cube, when you apply some forces at the top of this cube, what will occur? As the bottom surface is stuck to the table, when you apply the force at the top, what will occur? The shape of the cube get changed. Initially it is like this. Now by applying the force here, it goes like this. That is what? Change in the shape. Now here, original position is like this. Slip position we can represent it like this. So as we have applied the forces, there is change in the shape like this. Now this is the change in the shape, and this was given by this angle theta. If you have the book, in your book figure 6.3 they have mentioned, in the same figure they have mentioned this. So tangential forces applied divided by area of this particular cube, that will give the shearing stress. In this fashion we have seen what are the stresses. So all these three stresses we have finished. Now let's go to the strains. So what is the formula for strain in our case? I will write here. Strain equal to what? CID divided by OD. Change in dimension divided by original dimension. So first we will see type of strain now. What is the first type? Longitudinal strain or tensile strain. It equal to what? Change in dimension divided by original dimension. What is changing? Length is changing. So change in length is suppose small l, original length is capital L that we have seen initially. Then this is said to be longitudinal strain, or sometimes it is said to be tensile strain. Let's go to second one. Volume strain. So that is nothing but a volume strain, or just a volume strain, just they have mentioned. So what is the volume strain? Changing dimension. Which dimension is going to change? Volume is going to change. So here change in volume divided by original volume. Suppose change in volume is dV, original volume is V. Application of force on the balloon. So dV by V. This is said to be volume strain, and here the minus sign always come. What is the meaning of this minus sign here? The minus sign is applied because when you apply the forces from six side on the balloon, it is seen that the volume of balloon is decreasing, and this minus sign shows volume of balloon get decreases. That's why the minus sign they have introduced. This is nothing but a volume strain. Third one and the last one, strain, that is nothing but what? Shearing strain. So what exactly this shearing strain is? Shearing strain is nothing but what we have seen, change in dimension divided by original dimension. So for this is nothing but what? Change in dimension divided by original dimension. As the initial cube is like this, when you slip it, apply the forces here, it goes like this because the bottom is fixed. So original position, and this is nothing but what? Displaced position. Then between these two surfaces, here somewhere it is theta, angle theta. Okay, so here shearing stress is what? The lateral displacement of the two layer, divide by original length of the cube. For example, I will draw only one side. Suppose this is initially one side of the cube. Okay, when you apply some forces at the top like this, we apply the forces. This part is fixed. This part is stuck to the table. Then what will occur? This side get tilted like this. Side initially like this, now it get tilted like this. By some angle, it is suppose theta. And this length here, this length is suppose L, original length. And lateral displacement, initially it is here at point A, it goes now to the point A dash. And this length is for delta L. It is said to be delta L, and this delta L is said to be lateral displacement, change in the shape of the object. So here shearing strain is what? Lateral displacement divided by original length. So it is delta L divided by L. If you see this theta, if you find out tan of theta, what is tan theta? Opposite side divided by adjacent side, delta L divided by L. So this must be equal to tan of theta. If this theta is very small, tan theta is approximately equal to theta. So this part we have to use further. So this is nothing but what? The shearing strain. So in this fashion we have learned the three type of stresses, three type of strains, their formulas, how they work, that we have learned. So the next topic in your next next lecture we will take. In the next lecture we will see the Hooke's law. That is the next topic of your syllabus, Hooke's law, and different things we will see in next lecture. Now all of you have to just whatever I had taught you today, you have to revise it at your home. You have the book with you, just open the book. Whatever the topic I have taught you in this video, try to read the same topic at least from your book. And definitely, whatever things you got here, after reading the same topic, your understanding get increased. Don't forget to read the same topic. I hope you got this. Still, if you have any one of you have some problem with this concept, whatever I have taught you, if the concepts are not clear, if you have some doubts, you can just message me on my WhatsApp number. That everyone, all of you have my WhatsApp number, I think. If you don't have, I will mention it in the description. Just message me regarding your doubt. I will try to solve your doubts. So uh, today we will stop here. Next period we start with the next topic. I hope you understand it very well, and just try to read the same topic and try to understand the same. I hope you are going to read it now. Next period we start with the husla. So please take care, and just don't go outside without any work. So be safe. Thank you.